Let's see how we manage errors better in Java using what we call a try-catch block, which is the strategy of exception handling for the Java coding language. Just a quick overview of what I'm doing here. I've made a public runner class and then also made a kind of local exception handling class that I'm instantiating so I can run its constructor and get my program up and running. I've also imported a scanner that's accessible in my exception handling class so I can run with my scanner, just so you know what I'm working with here. So in this start program, I'm going to show you kind of what are the common problems that we can come across in things that we code. What if I ask the user to please input a number? And then what I did is I said the num_in equals my scanner dot next int, because I wanted to just get an integer read in. I'm not even going to process this right now. I just want to show you that if I run this program and I actually, once it loads up here, let's go, just type in a normal number, then my program's happy and it completes. But what happens if I accidentally have a finger slip and I say 1A? I put a letter in with a number. Command execution failed because it crashes my program. I'll show you that it crashed here because I'm going to have an output after this. It worked. And if I try to run my program, I should see this run if my program didn't crash. But if I just type in, I don't know, a bunch of letters, bang, it crashed. There's errors going on. I wasn't able to run, and I don't see this it worked popping out because I have, well, it tells me I have this exception in thread, an input mismatch exception, which is interesting. So what's going on here is I don't have the right data type being assigned because I sent a string or a character instead of an int. And so I'm having this issue make my program crash and not reach the next part of execution. So I need some strategy for being able to deal with what if my user typos or doesn't listen to instructions and inputs something different than the number that I'm requiring. So this is where I'm going to be able to work with this structure, called the try-catch block. And it's how we generally like to write it. Try with squiggly brackets, and then the word catch with open and close brackets, and the squigglies after it. You can write it like this if you want, where they're on different lines. I kind of like to write catch on this next line because they're kind of attached to one another. It's a syntax that I kind of like. You can have the squiggly back a little bit as well. It's all just about kind of your own personal preference. And the idea here is that this is the code that you're attempting to run, and catch is responsible for intercepting anything that will crash your program and then dealing with it externally or in some different way. So what I'm going to do is I'm going to move the content of this logic inside here and just space it out properly. So what I'm going to do is I'm going to try to print out this instruction and get a number sent in and then say that it worked. And then I have to catch something. I need a piece of information in here though. And the generic case is I can just look for an exception, which I also need to name. Normally we call it E. Some people call it EX, or you can even just call it exception if you wanted to. And what this does is actually stores a message that's printed out from, well, Java itself that tells us some information about the exception. So I'm just going to have my program print out whatever is in this message just so I can see what it is when I run this. So first of all, let's just test this and make sure that it's running properly. When I type in the right information, anything different about how we see things, type in a number, here's the number 1, and it worked. Let's zoom in a little bit here. It worked, just like we would expect, because I typed in the right information. But what if I run this again, and this time I typed in hi. This time my project doesn't crash, but I still didn't actually see this message it worked pop up. So I type in hi, and it prints out input mismatch exception. This is the message that it caught that tells me what type of exception was found and what Java did really to avoid the crash. And what it did was it recognized that there was something wrong with the input and said, you know what, there's an error here, but because you caught it, I'm going to allow the program to continue running. And it does that by skipping everything else in the logic and is moving on to whatever's outside of the try-catch block. Let's just see here. I made it out. If I run my code when I actually allow it to run properly, down here, type in the number 1. I see it worked, and then I made it out. It worked because this succeeded, and so it allowed the next piece of logic to run. And then I made it out because the program continued after it was finished. However, if I type in an incorrect piece of information, like hello, then it only says I made it out. That's because the exception catch stops running the logic where the error occurs and just kind of nullifies the rest of the content after it, skips over, and kind of says ignore everything else. Something's going wrong, so ignore everything else. We're just going to pretend that never happened, and we're going to move outside into the next part of logic so the program can continue. So this allows an error to be put in, but not actually fully break the flow of our program's logic. I could use this to even greater effect by forcing correct inputs from a user in this context. What I might do is, around this try catch block, I might say correct input. I'm going to assume it's false. I'm going to assume the user had an error. That's set as a Boolean. And I'm going to say while not correct input. I'm going to continue to loop this ask. So what's going on in here? And I'm going to say I made it out to only print once I make it out of this whole scenario that's being looped over. So now what do we have here? I set up an initial state, and I'm looping until it's set to be true. And what I'm going to have happen here is I'm going to try to get an input and only set input to be true after that input's gathered. Because remember, what we just talked about, and I'm leaving this space here intentionally just to show you that if this fails, the exception is going to be caught, and it's going to skip everything else and continue on. But because we're in the loop, it's going to kick us back to the start and then try again. So let's see if I've created this properly and if it plays out as we expect. Now that the loop is here, if I try to type in a number and I type in A, it's going to say input mismatch exception. Aha! And here's where, I'm glad this happened, we can see this annoying little bug that happens sometimes with our scanner, where the next int didn't gather all the input information. There's actually still an enter key press hidden away there that's being processed over and over and in this infinite loop. So I need to remember to do is, after I've got a scan next int type input, I need to clear my buffer of my scanner. And the right spot to do this is actually in my catch. Because if I try to do it on this next line and this fails, this next line isn't going to run. So I'm not actually going to clear the buffer properly. So what I might do here is just say if something went wrong, I'm going to just clear all the data by just doing this buffer clear, just getting all the data sucked up, which is now going to allow this to work properly. If what I just did doesn't make sense to you, please ask, because it's one of the most obnoxious quirks about the strategy of input that we're using. That's really important to understand. Okay, so input a number, I'm type in A, and here we go. Now we get the input mismatch exception. To make this even clear, instead of just printing out this exception, I'm going to change this message to say, you typed something wrong. Try again. And not even print out the exception information. Technically, that's just for the coder's understanding. The user doesn't need to know that. So now if I type in something incorrectly, let's let it load down here. A, you typed something wrong. Try again. A long string. Mixture of letters and numbers. Nope, it's not letting me through until I type something in correctly, which is a number. And now that I typed a number, it works and I made it out. But it forced me to continue to input until I got it right. This is super useful for menus because it's probable that your program logic requires you to have the user give you information that you have anticipated. And so you need to limit what they're able to type to just the things that you know how to process. And this is a great strategy if you're dealing with bad int inputs coming through. And we can deal with lots of types of exceptions this way. You could, in fact, deal with the input mismatch exception directly if you wanted to. We can actually just change a couple small details here. Instead of just saying an exception, I can actually specifically look for this input mismatch exception. And Alt-Enter, I need to import it when it's more specific like this. Oops. But now that I've imported it, why is it loading up the documentation? I have this input mismatch exception imported. And it's going to deal with this just like it did before, but it has only this specific exception being checked. So in this case, again, something wrong, until I type in a number, and it worked, and I'm done. So it's kind of doing the same thing as the general exception did. So what's the advantage of the input mismatch exception? Well, because it's a bit more specific, it's not looking for other scenarios, and it's a little bit more efficient. It also showcases your understanding of exactly what we're kind of looking to avoid in this circumstance. So I like to see it because it showcases your depth of understanding here. Okay, so let's look at our third scenario, an arithmetic exception. I want to show you a couple more examples of where things can be dealt with. Now, you could just use the generic exception for this if you wanted to, but let's do the arithmetic one just to be thorough in understanding. So our arithmetic exception here, I'm going to be looking for this, and what I'm going to be doing here is please input a number to divide by. And in here, I'm going to have my num1 just be, 5 for now, but I want the num2 to be the number that's input by the user. So in this case, what am I doing with this? Well, I'm going to have another int result be the, I guess you call it the, what is it, the dividend? What's the result? The dividend? The result. Let's call it the result because I forget what you call the term. And I'm going to have it be num1 divided by num2. And then I'm going to print out, it worked, the result is, and I'm going to concatenate the result onto the end here and see what the result is from this calculation, and allow the loop to kind of require things to be input until it works. So what's going to be the issue here? Well, what if I divide? I don't know. What if I divide by 2? What's the result going to be? And in this case, the result is being shown again. 5 divided by 2 is 2 because it rounds down. 5 divided by 3 is 1 because it rounds down. What about 5 divided by 5 is 1? It goes in evenly. 5 divided by 1 is 5. So the math's all working out, but I want to see what happens if I type in 0. You typed something wrong. Try again. Why is it saying this? Well, we're not allowed to divide by 0. That's not allowable in math. It doesn't make sense to divide by 0. And this arithmetic exception looks for things that break the rules of math and prevents them from crashing our program. If I didn't have this exception in here, then my program would have crashed after this was performed because I'm not allowed to divide by 0. So arithmetic exception can catch, when you have mathy things going on, it can catch things kind of like dividing by zeros so that you don't break the rules of math and crash your program. Okay. Last one here, index out of bounds exception. This one is particularly useful for when we're trying to access information about arrays and data structures. So in here, let's not even loop around it. Let's just kind of go back, and I'm going to create this from scratch again just so we can see one more time how this is all built from scratch, just for review's sake. So let's back up here a little bit. And the index out of bounds exception. So what if I just have oops, hit the wrong keys there. An array of nums, and I want to say, let's initialize it with just 1, 2, 3, 4, 5. Give it some initial values. And so in this case, what I can do is, well, print out maybe value is, and I'm just going to concatenate the value of nums at some slot that I'm accessing. So what if I'm printing out in slot 0? And maybe you want to add in the user can choose which slot to access. I'm just going to manually do it for right now. But what's the value in the element 0? The value is 1. That's the first entry. What is the value in element 4? Well, let's find out. Hopefully, as a little review, you predict what it's going to be. Hopefully you got 5. That's the last element. It's always length minus 1. But what if I try to access element 5? What's going to happen here? Well, hopefully, as you might have guessed, error. Array out of bounds exception happens. So this means I've gone out of the range of the array and crashed my program. Oh no. So what if I allowed the user to pick and choose an element to look at? Chances are decent that at some point the user is going to choose a slot that's not allowed and crash your program. So what can we do about that? Well, we kind of know the strategy now. A try, catch, block to catch our index out of bound exception. And I'm going to have a message that says, you went out of bounds. Choose a different element to force the user to pick a better one. And then inside of this try block, I'm going to put this logic with my information here and process the information like so. I didn't put a loop here. You can always do that yourself as you experiment and test alongside, which is always a good idea while following these tutorials. And here I see the message pops up. You went out of bounds. Choose a different element because I was out of bounds. But notice, build success. The program didn't crash. By catching this type of exception, I was able to avoid the program crashing. So here we go. We have these try-catch blocks that we can use either generic exceptions, which will work for the most part, or if you want to impress me, you can start using some of these more specific ones. And you can do a Google search for other types of exceptions Java offers, although a lot of them are kind of outside of the scope of what we need to know right now. But I want to see you start to include try-catch blocks wherever you anticipate input data might accidentally break the flow of the program's code. A try-catch block will help prevent that from happening in ways that you can manage the result without breaking things.